Alright, in this video, we're going to talk about the last two solutions for what values of a and b will the function be continued everywhere. So the keyword will be continue. You see there is a piecewise functions, right? So we're going to look at the piece by piece. Now, what I want to know it is to review a little bit. Think about a function. So you notice 2 kind of like a special location. So I'm going to make up the 2 is right here. So what do we notice about? We know there are 2 pieces of my picture. If I coming, or you can say that less than 2, which will be on the left side, I have a function, it's a parabola because the power is square, right? So it may look like this, but I cannot equal to 2, so I shall have an open circle. Very good. Then you know that, well, bigger than or equal to 2 give me it will be the right part of the graph. That can be a straight line, right? At this moment, you know that it will be a horizontal straight line. What is it tells me it is the 2 will have an outcome. So I fill in my open circle. So that is continue. So that gives us, we will just look at that as the left part and the right part, they continue. So they will equal to each other. So what you see is what you got. So the ax squared minus 3x is my left part. And that will equal to the right part, which will be the 2a plus 1. Now we agree the critical location is at 2. So I'm going to plug in the 2. So what you see is what you got. A times 2 squared minus 3 times 2. That should equal to 2a plus 1. Very good. Housekeeping. Be patient. So that will be 4a minus 6 equal to 2a plus 1. Housekeeping. Both sides minus 2a. So I got 2a. It's equal to both sides plus 6. So that will be 7. What can we do? We say that both sides need to divide by 2. So a is equal to 7 over 2. Perfect. Do not overthink. What you see is what you got. And yes, indeed, we do not need a calculator. Good. All right. Number 16, the same thing. Activate your ego eye. You know that Ms. O said that I'm going to look at the critical value, something special about the x, the domain. So you notice less than -3 and the equal side kind of made those -3 as my critical location. What else do you notice about? Oh, I also have the 2 as my critical location. So that tells me I will have a 2 equation. I'm going to set it up as a 2 equation to do it. So remember, we talk about from left, from right. So the left part equal to the right part. So one at a time. So if I look at my 2x plus 5, anything less than -3, that shall equal to the next part will be ax plus 5b. It's at the trouble when x equal to -3. What do? We say that plug it in. So I shall have 2 times -3 plus 5. That is equal to a times -3 plus 5 times b. Very good. Housekeeping. Can we do a little bit more about that? Yes. So 2 times -3 would be -6 plus 5. That is equal to -3a plus 5b. Can I continue? Housekeeping? Yes. So I got -1 is equal to -3a plus 5b. You may say that, Ms. They are too unknown. It's okay. Leave me alone first. But I do know that this will be my first equation I'm about to use. So that will be my first equation I'm going to use. Now, what will be another condition we can use? We talk about it will be the 2. So the 2 is from those 2 trouble right here. So we got ax plus 5b should equal to x squared minus 2x plus 3 at the special location when x equal to 2. What do? Plug it in, plug it in, plug it in. So I got a times 2 plus 5b equal to 2 squared minus 2 times 2 plus 3. Housekeeping. 2a plus 5b should equal to 4 minus 4 plus 3. Can I continue to do housekeeping? Yes, I got 2a plus 5b. That is equal to 3. Now, what you see is what you got. You notice, this is my second equation. I don't know yet, but I'm going to figure it out. So that tells me I'm going to use those two equations and set it up as a system of equation to solve it. So here we go. Here we go, go. What you see is what you got. Now, I like to make everything look fancy, so I'm going to write this as negative 3a plus 5b, that is equal to negative 1, and 2a plus 5b is equal to 3. So what do you notice? You can say that, oh, you know what? If I subtract them, which will be negative 3 minus 2. That will give me negative 5a, but my 5b minus 5b is canceled out. Very good. And negative 1 minus 3, that gives me negative 4. So I know my a is equal to negative 4 divided by negative 5, aka my a value is equal to 4 over 5. Look at that. Ooh la la. No need calculator. Now, if I need to figure out the b value, what shall I do? Well, if I want to figure out the b value, I got to go back to the equation that involving the a and b together. So be my guest. Which one would you like to use? So I'm going to substitute that back to my equation 2. So this is my strategy. So I'm going to back to this one. So what do I got? I got 2a plus 5b is equal to 3 because I know a. So I'm going to plug it in. So 2 times 4 over 5 plus 5b is equal to 3. Yes, no calculator. So that tells me housekeeping. I got 2 times 4 will be a over 5 plus 5b should equal to 3. I'm going to both sides minus a over 5. Now here comes the trouble. We do not like the denominator. So the denominator is 5. So I'm going to make everybody have a 5. So 5 over 5 underneath the 3. So that means 3 had to times 5. That gives me is what? 3 times 5 will be 15. So that tells me it's a 15 over 5 equal to 3 minus a over 5. That is equal to 5b. So what do I got? 5b is equal to 7 over 5. Almost there, okay? So what shall I do? I don't want 5b, so I need to divide by 5 on both sides. Now here, I must say that the common mistake. Don't say that, oh, the final answer is 7. Nope, no. All right. So you okay about 5 and 5 cancel out, so I got b. That is equal to 7 over 5. Divide means times. I'm going to upside down the 5. So 5 over 1, when you upside down, that becomes 1 over 5. So aka my b value is equal to 7 over 25. So again, no calculator. No calculator. So now I know that b is equal to 7 over 25. And this is what we mentioned about fun thing about calculus. We do not need a calculator, okay? But the algebra cool to guide us through. And that's all for today. Thank you.